So I think everyone installed that ME stability yesterday.
Yes, sir.
Those who have not installed, please install the package ME stability by using this code first line. I will show you. Because this stability you need to practice. Nowadays it is like a trend for analysis or stability analysis and integration of different models. So those who left for installation of this ME stability, they can just copy this first line and just they can paste it here. It will install. And then run the library command for ME stability. And if you don't have agricoli package also, just install it and run the library command. So everyone finish up to this and let me know. So today we will see this ME stability with a default data set. Every package is having one default data set. So with that default data set, we will see what is the output of this ME stability. So up to this, it's I think fine. Yesterday only we did this. Is it?
Yes, sir.
If anyone is getting any error up to this, let me know. So nobody is having error.
No, sir.
No, sir.
Okay. Yeah, so now do one thing. Just copy this. This is PLRV is a default data set for this ME stability. Just copy this command and paste. You will get data set in right hand side in your global environment. Just you can click on that data. Here you will see the genotype, locality, that is in our case it was environment yesterday, then replication, and then these traits. Arun, just mute your mic. Arun Kumar. Sir, please mute your mic. Then after the data, just copy that model command. And press enter. So now you have set one model, that is PLRV is your input file. Then here locality means your different environment, that is the column. Then genotype is represented by genotype, replication by REP, and trait, here it is considered as a yield. Then next is just copy this ANOVA command, you will get ANOVA for this trait. Many people are asking this significant level, why 1, 2, 1 and 2 we know generally, but why these 3 stars? So this 0.001 means 2 star, 0.01 means single star, 0.05 means dot. Then here, this model analysis will give you the principal components. Here it is 5 principal components are there. Then this model biplot, that will give you a biplot values. That is for trade yield and values for the PCA. 5 principal components are there, so it will give values for all 5 PCs. And then next, you need to copy this AMI stability. Total command and just paste in it. So after pasting, you will get values as well as number of diagrams. So up to this completed,
Yes, sir.
Sir, kindly repeat.
Yes. Give me 1 minute. I will
Okay, sir.
repeat this. Yeah, so here, yesterday we tried this AMI stability, but we got some error because of some similar values in our data set. So today we are dealing with this AMI stability with a default package data. As you can see in chat box, I have shared a small parallel, small commands for AMI stability. So we will do AMI stability by using these commands. So first, yesterday only we installed this AMI stability package.
Yes, sir.
Then we ran the library. Then again we installed Agricoli yesterday with library. Then this PLRB is a default data set. Just you can copy this data and you can paste, you will get the data set. What is showing, I am showing on the screen. So this data set is there. And then after that, just simply you need to set one model to analyze this AMI stability. And after that, after setting the model, we need to calculate 3 aspects. That is, first is ANOVA. Here it is ANOVA. Then second is principal components. And third one is biplot values. And after that, in AMI stability, there are different stability parameters. So that needs to be calculated. So for that, here is the one command, that is AMI stability. Then the model we have set earlier, and then this stability parameters. So if you copy, paste and enter, you will get the 5-6 diagrams, and this stability parameters tables are there. Okay. So just see the first diagram, that is saying as correlation between different AMI stability parameters. Just zoom it. So there are number of diagrams. Just use this. These 2 arrows are there. Just see the screen. These 2 arrows are there. Just use these arrows
Sir, I've shared you one screenshot. I'm getting error.
So madam, don't edit the command. Use the command from chat box.
Hello, sir.
Sir, can you share on what?
Commands are
Yes, sir.
that
Yes, sir.
AMI stability commands are there in chat box.
Sir, can you please share these commands
Just
on
see the
WhatsApp
screen.
group?
Just yeah. Now the commands are in WhatsApp group.
Okay, sir. Thank you.
So just complete it and open this first and zoom this first diagram, that is correlation between different AMI stability parameters. Complete up to this and let me know. Completed?
Yes, sir.
Yes,
Can
sir.
you please check the message? I have sent you one query. Number 9057.
Just listen everyone. There are these arrows are there. From by using these arrows, you can get to start. So just make use of these arrows. You will see the diagram what I am showing. So run the AMI stability library. Your error will be clear. Number ending with 4059. Every time, don't forget to run the library commands. If you forget to run the library commands, it will show error. Got it?
Yes, sir. Yes,
Yes.
sir.
So just zoom this first diagram. And if you can tell me any one or two members, what you will come to know. First impression.
Sir, value 1 will show absolute stability.
Okay. So actually, this diagram, or else it will be better. This only. Yeah. So this diagram, just it is a representation of correlation between the different stability parameters. So as there are different stability parameters. So now can you tell me any one or two members? Anyone is having any idea? What are these short forms?
Sir, this will suggest that if we talk about the character, two characters, so if one will increase, then other will automatically increase.
So actually
So
it is
the
not
one value,
characters, madam. Thus you are saying character, but your interpretation will match with a correlation diagram. This is a correlation diagram, but it is not with the characters.
these are the parameters. Okay.
These are the stability parameters, means these are the factors which plays an important role in stability analysis.
Yes, sir.
So here this diagram will show us the correlation between different stability parameters. Likewise, SIBC, MASV, these are some parameters. So now we will see one by one. What is SIPC? So SIPC is, the full form of SIPC is sum of absolute value of interaction PCA score. Sum of absolute value of interaction PCA score is nothing but SIPC. Then next is MASV. Just you can record somewhere else in your diary or whatever it is. MASV means modified AMI stability value. MASV means modified AMI stability value.
Sir, kindly repeat for SIPC.
Okay. SIPC is nothing but sum of absolute value of interpretation PCA score.
Yes, sir.
Then MASV is modified AMI stability value. Then third, that is EV. So EV is nothing but eigenvalues. So where we will get these eigenvalues? In principal components. So then next is avenge, EVAMGE, AMH. So that means the sum across the environment. AVAMGE, that is stands for sum across environments of absolute value. So that means these parameters They are used to assess the stability of a particular genotype across the environment. That's why every time they will calculate the sum. Whatever your absolute value, they will calculate the sum across the environment. That we used to tell G into E. So that means the interaction of genotype and environment. So the performance of genotype across the environment. So for that purpose, they will calculate the sum across the environment. So your next parameter is ASV, that is AMI stability value. And last is sum across the environment of G into E interaction. So first one is sum across the environment of absolute value of G into E. And this last is sum across environment of G into E interaction. So these are the 6 parameters on which stability.
Can you repeat, sir? Repeat, sir.
Which one?
From
Sir,
AMC,
last
sir.
AMGE.
AMGE is sum across environment of G into E interaction.
Sir, can you please repeat SIPC?
Hello, sir. Can you please check the WhatsApp once? I sent a image. Last is 8857.
Yeah.
Okay, sir.
Any problem?
So the graph is different.
So everyone, please listen. Keep your whatever you are listening aids you are using. So these 2 arrows are there. So like our mouse, we have one scrolling button. So with the help of these 2 buttons, you can change this. Just to see. Over. Now I will come back again. Again I will go. Again I will come. Don't afraid clicking in the software. Nothing will happen. Nothing will happen to your laptop. If anything will happen, just Control Alt and delete. If you press these 3 buttons at a time, and you can shut down your laptop will be okay. So don't afraid of clicking here. Nothing will happen. So here, a new diagram, that is correlation between different AMI stability parameters and corresponding simultaneous selection indices. So in first, we saw the correlation between different AMI stability parameters. In this, you will get to know the correlation between this stability parameter along with the simultaneous selection indices. So now what is meant by simultaneous selection indices? So simultaneous selection index means what? So this is a method in plant or in animal breeding also it is useful, that evaluates the multiple traits. As now we have seen there are four different traits in our input file. So it evaluates the multiple traits simultaneously. And among that multiple traits, it will select the best genotype that you can use for your breeding program. That is called as simultaneous selection index. I'll repeat, simultaneous selection index means it is a breeding method in both plant and animal breeding. This concept is used. This concept will evaluate the multiple traits simultaneously and select the best genotype or best individual that a breeder can use for his breeding program. So here you will see the correlation between different AMI stability parameters and corresponding simultaneous selection indices. So here you can see this correlation. Here it is 0, neutral, positive, significant 1, and it's negative -1. As you may have well aware, correlation is in between -1 to +1. So according to that, here it is represented. I hope everyone is getting what I am telling.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yeah. So we'll move towards the next. This is something new. Anyone saw this earlier?
No, sir.
No, sir.
No, sir.
So here it is, you can see at the bottom. First is mean values. From second onwards, different parameters are there. Okay, so this is first graph. We'll come back on this. And here, this is second graph. As we have seen two graphs earlier, correlation between different stability parameters and correlation between stability parameters and the selection indices. So similarly, this is called a slope graph. This type of structure is called a slope graph. So what this slope graph will do in stability? So just it will, this is a line diagram, you can say, line graph. So it will provide like, here you can see the mean. So it will provide the relative increase and decrease in various categories. So here the categories means our stability parameters and stability parameters with selection index. So here you can see the first graph. Here in first row, it is a mean. And the increase and decrease of this according to genotypes and these different stability parameters. It is just showing the increase of performance of genotype and decrease of performance of genotype first on the basis of stability parameters. And secondly, it will show on the basis of stability parameters along with simultaneous selection index. So these are the two graphs of stability parameters and stability parameter with SSI. That is simultaneous selection index. Yeah. So now this. So generally what we'll call to this type of graphs in our local terminologies? Some will call it as a histogram
So heat map.
or heat map. Okay. So mostly we'll call it as a heat map. Is it?
Yes, sir.
Yeah.
Yes, sir.
So here you can see it is nothing but again same stability parameters. Here you can see the left hand side corner, lower side, left hand side. Here you can see the different graphs we got. First is stability parameters and selection indices separate. Then a combined stability parameters and selection indices. Third and fourth is slope graphs, what we have seen. And now these two are heat maps. So as we have explained the slope graphs, in the similar way, the estimation of heat maps are there. So all these are the diagrammatic representations, and if you want tables, it is there on your left hand side, as you can see on the screen. All these are, you can copy this and paste into text file. And you can export easily into Excel.
हेलो सर।
Yes.
सर ये हीट मैप से हम कैसे कंक्लूड करेंगे कि विच जीनोटाइप इज मोर स्टेबल?
It is not about stability, these slope graphs and these heat maps. That's what I'm telling. It is just a relative increase or decrease of performance for that particular character on the basis of stability parameters and selection indices. When you will estimate the total data, means total AMI, means that from initial biplot to AMI stability and GGE, you will come to know one by one everything. So here in your left hand side, that those values are there. So from that values easily you can estimate. You can interpret easily, values are there. Which one is higher, which one is lower. Yeah, so in this, who is getting error? Because only 3 or 4 members are speaking.
नो एरर सर।
So what about other members?
No error, sir.
No
No
error,
error,
sir.
sir.
No error.
Okay.
Sir, text file कैसे सेव करना है?
Text file simply you can copy, madam. Now see this stability parameters. Simply you can copy this and just open the notepad and paste it. And you can save anywhere in your system. Simply the same way, this values for simultaneous selection index and this correlations also. So nowadays, if you have data sets, people used to calculate this AMI stability for short communications. You will see.
Hello, sir.
You will see if you will search it, you will see the short communications papers.
Sir, can you please explain the slope graph again?
Okay. Yeah, so number ending with 4059. This AMI stability, you will get to know the correlation between different stability parameters and SSI. To select the best genotype, what we have already did yesterday and day before yesterday. So those things you have to follow.
सर ऊपर जो टेबल आती है उसका सिग्निफिकेंस क्या होता है, मतलब उसे कैसे रीड करना है?
Which one? This
जो
one I have
passport के ऊपर-
highlighted.
नो सर, उसके ऊपर है ना जो हमारा एक्सपोर्ट वाले, उसमें ग्लोबल इन्वायरमेंट में क्लिक करते तब आता है PLRV, या फिर मॉडल पे क्लिक किया तो जो साइड में डिस्प्ले होता है।
हाँ, this PLRV is a data set, madam.
ये इनपुट डेटा को रिप्रेजेंट कर रहा है ना सर ये?
हाँ जी, input file. And this model is nothing but what you run this command. You set this model, no? So that is that model. If you will click it, it will show the different what the data set is.
ओके सर।
So now just see, I will show you yesterday's diagram. Yeah. So here you can see, I will repeat this total along with now here in this file I have given the names for each and every graph. So here you will get to know clearly. So yeah, so yesterday we did, if you can open that code file. So everyone, please open that code file. So here we calculated AMI ANOVA, AMI PCA, AMI means, right? For particular characters. So here you need to represent each and individual character along with your AMI biplot. So here These are the percent contribution of each principal component to the total variation. So that means these all are the source of variation. And this is particular character and these are the percentage values. What percentage values? Means this is first source of variation, that is genotype. Genotype is contributing 15.91% to the total variation. Then environments are contributing 80.91% and G into E interaction is contributing 3.18% to the total variation. And these three principal components are there. First is contributing 46, second is contributing 31.8, and third is contributing 21.7. So with that, total cumulative is 100%. So this table you need to give, and below that you need to give these two plots.
सर इन बाय प्लॉट से हम ये कैसे इन्फ्रेंस कैसे ड्रॉ कर सकते हैं जो टेबल में वैल्यूज आई हैं
Then madam, same what I told her, it is nothing but what are your sources of variation and how much percent they are contributing in the total variation developed for that particular character. That is your interpretation.
Can you repeat, sir?
पर सर अभी तो जैसे वैल्यूज अगर हमें ना दिख रही हो तो बाय प्लॉट से तो हम कुछ भी नहीं लिख सकते
बाय प्लॉट से तो मैडम कोई कुछ अभी जैसे
नहीं कर पाएंगे ना
think of it. If you will open any cell press or theoretical applied genetics paper, table will be there, no problem. How crystal clear diagrams are there, but the representation, any scientist will do representation from numbers only.
ओके सर
Sir, in the
Then
R script,
if you will open molecular breeding paper, that diagrams are like that, even if you cannot see the diagrams, but still the world is saying it's wow.
जी सर वही वो सुंदर सा दिखना चाहिए बस
Yeah, world is saying wow, what a nice and crystal clear, fantastic diagram. So cell press price, that publication price is almost 3 lakhs. It will accept.
Hello, sir.
So it is a game of representation. Numbers will be there everywhere. Yes, sir. Tell me.
sir, I have
Sir,
one
in this table, sir, genotypes is contributing 15% contribution, almost 16, and environment is playing the major role. So this means that our germplasm, whatever we are studying, has not significant variation. Because we can clearly see that environment is
how you are saying that? Tell me.
on this table the character representing C1.
Okay.
Based on
Your voice is breaking.
So based on the C1 character.
Okay.
So C1 character, in C1 character, genotype is not. I mean, sir, environment is only playing the major significant role in
So
the.
how much, according to you, how much contribution should done from genotype sites, according to you?
No, actually, first of all, sir, I don't even know the C1 character. Which character is this? This is the only code you have given. It can
So
be
just
80%.
assume something.
Like
If suppose number of parts per plant in case of groundnut. So this table is for number of parts per plant in case of groundnut, and then tell.
Then, sir, on the basis of number of pods per plant in groundnut, environment should not play 80% role.
Why?
Because if environment is playing that much role, then how can we select the genotypes then, sir?
So listen, this is a experimental. So if you will say, I studied 18 characters in my PhD research, so all 18 should be significant. This thing will never happen.
Yes, sir.
If you will say, I have made 100 crosses, and how it will become like only 2 crosses are significant means I am wrong. It will never happen. If you will go through all the literatures, even if you will talk with all the seed industry people, they will say like, we will develop 5,000, 10,000 crosses, and from that crosses we will get only one. If industry people
Yes,
are there, they will agree with my statement. So 16% means it is not non-significant. It is just a number. Maybe sometimes now see, in your June to November, it is regarded as a rainy season as per our thumb rule. Correct?
Yes, sir.
So
So this can be known.
so still in some areas in June to November temperature is 40. So then what you will do?
Right.
So don't forget, you are a researcher, you are doing a field experiment. That is not in your hand. Though you are following RBD or any design, though you are following all the rules and terms and condition, everything. So just a small question to everyone. If you are following all the experimental design terms and conditions rule, why we get a standard error? Most of
Sir,
them are MSc and PhD students, so they can tell why we
sir,
get a standard error.
due to environmental factors, uncontrolled error creates or soil heterogeneity.
Correct?
Uncontrolled factors.
Variation among the soils.
Yes, sir.
So in short, we'll call that standard error as some error due to uncontrolled factors. Correct? As madam, you
Yes,
first and foremost, you told
Yes,
the
sir.
environmental factors. So that means whatever we planned, whatever we are planning, so there is a major role of environment.
यस सर सर एक्चुअली मैं ये जानना चाह रहा हूँ कि अगर जो यील्ड एट्रीब्यूटिंग ट्रेट्स है हमारे सर जो फाइनली
हाँ।
यील्ड को गवर्न करते हैं
हाँ जी।
तो सर उसमें तो वेरिएशन जीनोटाइप्स में ही आना चाहिए ना दैट्स व्हाट आई वांट टू नो दैट
where it is written.
नो इट्स नॉट रिटर्न बट
So
एज
means
अ
I
प्लांट
will tell
बिल्डर
means I yeah. If you are plant breeder, so your aim is, so just be attentive and please listen my sentence. The role of plant breeder is not to select the desirable line. Plant breeder is the when you call yourself as a plant breeder, when you can reject the germplasm. Anyone can do selection. BSc person also can do selection. So this is a nice plant, we can select. But when you will say these are not good, that means you have your choice, you have your funda clear. So which we need to select and which we need to reject.
ओके सर
So
गुड
if as a
सर
breeder you have plan experiment, so that means that experiment will never fail. It can fail. फेल जा सकता है
एक्चुअली
वो।
विल नॉट फेल
100% आप सक्सेस होंगे ऐसा तो कोई है नहीं ना भाई।
Yes, sir.
You will never get 100% success. If you will try 100%, you will get maximum 1 to 2% success. 98%, still 98% failure will be there. That's why when breeder will develop one hybrid, that one hybrid will last for almost 10 years of his next 10 years service. He will enjoy the credit. He will enjoy the credit of that for next 10 years. So, okay, that is a different thing.
Sir,
Yeah, madam, tell me.
sir, in the R script, it is given one command print ME model comma digits equal to. Sir, what does this digits equal to?
1 minute. These digits are means if you run this command, madam, just run it. I will show you. As now this file, I will import that our old file. Just you can see the screen. You will come to know. Library. So that means here you can see these first two principal components. So that means whatever possible the numbers, please display the numbers in 2 digits only after point. That is the meaning of that command.
But sir, for other like PC3, it is showing more than
Whatever
two decimals.
after that command, whatever possible, madam, that only software will show.
Okay, okay, sir.
Means even if you delete that command, nothing will change.
Okay, sir.
So with this second character also, if you will see, here also environment is having more role. So actually this will depend on your data. So likewise, you have to represent this either in your paper or in your thesis. So in this third character, the contribution of genotype increase a bit. So likewise, this file is there. Again, the gene. Yeah, so GG by plot for one character we did analysis and we got almost 6 to 7 graphs. So here,
Yes, sir.
if you remember, this was the first graph that is called as basic biplot. And here the name given as inner product property view of GG biplot. Inner product property view of GGE biplot. That is called as basic biplot. So that inner product property view means it allows for the visual estimation of any element, whatever the elements are present in the original data matrix with respect to environment and genotype. So here you can see environment and genotype. So whatever the elements are present in the original data set with respect to environment and genotype, it is the representation of that.
So it allows visual what? Can you repeat?
Visual estimation.
Okay, sir.
visual estimation of elements present in original data matrix or data set. So then here, this itself, it is a heading that is, yes, madam.
हम उसको ग्राफ में कैसे विजुअल एस्टिमेशन करने वाले हैं वो आप थोड़ा बताएंगे क्या?
हाँ जी, हाँ जी, हाँ जी. So here, see here. So see the headings. GG by plot, scaling 0, centering 2, and SPV is 2.
Yes, sir.
So that means, it means that the value of genotype in a specific environment. So here you can see the arrow E2, E4, E1 and E3. So here the distribution of genotypes are there. So that means genotype, value of genotype in a specific environment can be approximated. Value of genotype in a specific environment can be approximated by the product of genotype vector length. So that means it is approximated by the G into E interaction, in short. That it will leads to study the performance of genotype and the interaction of this all 3 or 4 environments. So our next is mean versus stability.
Okay, sir.
Next graph is mean versus stability. So it is a simple, it is a visualization of G into E data. That is genotype interaction data, and it will highlight both average performance and stability. So see here 1, 2, 3, 4, all 4 environments are there. It will represent the mean values and stability across different environments. So that's why it is called as mean versus stability. Now here, third is which one where view of GG. So all these diagrams, all these are different biplots. So here, which one where means these are all 3, 4 environments. So which genotype is the topmost in different environment, it will identify that. It will identify the topmost, or you can say as a winning genotype across the environments. So here you can see this, all this 5, 6. It will give the representation like this. So then this next is discriminativeness and representativeness. So discriminativeness.
Sir,
Yes.
good evening. Sir, can you explain stability, mean stability, sir? Actually, which genotypes it is 80% stability, 90% stability. Can you say, sir? According to
So
figure.
just 20 minutes, 10 minutes before I told, sir, have you ever seen the molecular breeding any paper in cell press or anywhere?
Yes, sir. Yes, sir. Yes, sir. Sir, I have done one AMI analysis, sir, in eucalyptus clones.
Yeah, no,
But
no, no. Just
uh,
now you have asked me the questions, no? From the diagram, can you say this? Which genotype is stable?
yes, sir.
So have you seen any paper with only diagrams, interpretations are there?
Yes, sir. I have seen some papers, but not.
Without table, I am saying, without table, only diagrams.
Only diagram. I have seen, sir. Only diagram.
Just can you share it?
I'll share, sir. I'll share,
Sure.
sir.
There must be some supplementary files, sir.
Yeah, that's what I am asking.
Sir, hello.
So this discriminativeness versus representativeness graph. So discriminativeness means discriminativeness and representativeness. So discriminativeness refers to the ability of environment to distinguish between the genotypes. So as we'll say, like in this environment, this genotype is suitable, in other environment, other genotype is suitable. So that means the ability of environment to distinguish between the different genotypes. And the second is representativeness. So representativeness, as the name indicates, it is the ability to capture the overall pattern. So that means ability to capture the performance of genotype or ability to represent the performance of genotype across the environment. So likewise, see here number 8, number 22, 31. Here see number 1. So here 40. So this graph is showing the ability of environment to distinguish the genotype and performance of genotype. So it is the comparison of ability and performance. And this is the ranking of environment. And ranking of genotypes. So this is all the characters, diagrammatic representations are there. Yes, madam?
Sir, in conceptually, how, like, what is the significance of ranking environment?
So actually, this environment, you can rank in 2 types. That is favorable and unfavorable favorable and unfavorable environments. Okay.
तो सर
So
के
means
रिस्पेक्ट में उसको फेवरेबल अनफेवरेबल बोलेंगे, मतलब जीनोटाइप कोई ऐसा हम पर्टिकुलर सिलेक्ट करेंगे पहले से?
नहीं जीनोटाइप्स पे मतलब इंडिविजुअल जीनोटाइप्स पे नहीं रहता वो. अगर कोई if in any environment it will depend, we can call it as a favorable or unfavorable on the basis of the performance of genotypes.
Okay,
It is not like 1 or 2 genotypes is there or 2, 3 genotypes are there. So actually unfavorable is where your performance of genotypes is reduced. It is based on the performance of whatever genotypes you are screening.
okay, sir.
Yeah, so up to this, any questions if you have, you can ask.
Sir, good evening, sir.
Yes, sir.
Sir, last class you have told I will
Yeah,
explain
yeah.
adaptability and
Yeah, as
productivity.
sir, we have started this AMI, so in between I cannot stop now.
Yes, sir.
So
Yes, sir.
that's
Okay,
why
sir.
I
Actually,
didn't
sir,
started
actually,
this adaptability concept.
sir, actually, I have done one paper, sir, AMI analysis for eucalyptus clones, sir, already. But through the not
Okay.
R statistics, through
Huh?
crop stat
What?
7.2.
Okay.
Sir, even sir, spare 2.0.
Okay.
Hello. In
Tell
ICR,
me,
sir,
I'm listening.
ICR tool spare 2.0 in this
Huh?
actually in software actually that software explained productivity and same time stability and adaptability clones actually genotypes clearly, but here star statistics and same time crop stat 7.2 also not shows regarding those things like spare 2.0. So that is could not easily could not easily identify those things. As a
Okay.
breeder, we should know, sir, actually stability at the same time. Sir, we know that visually productivity and adaptability, but in graphical representation, we want to see that character, sir.
So,
But
okay. Yeah, I got
yes,
your
sir.
point.
Uh,
So, sir, R
but we
is
have
not
to
like
spend
that,
more
means
times to.
everyone. Yeah. So R is not like that, like most of our other software. If we'll input, if we'll give input file, if we'll click analyze, so it will give everything. Here, if
Yes,
you
sir. Yes, sir.
want to do different things, you need to
Hmm.
install a different packages.
Yes, sir. Yes, sir. But we
Simply,
should.
if you'll go to OPStat, if you'll go
Hmm.
input file, if you'll give input file, on single
Hmm.
click, if you'll analyze, it will give whole stability
Hmm.
in a single click. And for this 7 graphs and 2 biplots for AMI, we install 8 packages, sir.
Yes,
So
sir.
that
Yes,
is
sir.
the difference.
Okay, sir. But we can go through very
Yeah,
difficulty in not easy for
sir.
visualizing because.
This is difficult. That's why in demand.
Hmm.
It is
Yes.
difficult. That's why in demand.
Yes, sir. Yes, sir.
That is the thing. We can get in one click many aspects analyzed in different softwares are there.
Yes, sir. Yes, sir. But not shows in art statistics also those things.
Our
It is.
statistics are see, you can give 10 days gap, and after
Yes.
10 days, just you start with estimation of genetic variability and let me know your experience.
Yes, sir. Yes, sir. But it is
After
actually,
10
sir,
days,
some.
you will forget everything.
Yeah, it is human nature, sir. If not,
Yeah, that's what I'm
it
saying.
is human nature, sir.
Because
Marketing is in human nature.
nowadays we have so many works. What a man, what and how many will remember.
No, sir. No, sir. There
So
is no
for
chance.
that you need to practice this hour regularly, at least half an hour.
Correct, sir. You're telling it's 100% sure.
But here, as it is a open source, you need to invest some efforts here. It is not like
Sure, sir.
single click, you will get everything.
Yes, sir. Yes, sir. Understood, sir. But suppose if it is displayed like adaptability, stability, and more productivity. It is very useful to us.
Yeah, it is good. Even I will say it is like a 24 karat gold. But for that, to do in R statistics, you need to invest your efforts and you need to give time.
Yes, sir. Yes, sir. Yes, sir. And I think, sir, even I want one more session also for your lecturer.
Sure, sure, sure.
As for myself, sir, actually I have actually playing for 15 years in breeding,
Yeah, yeah,
but
yeah.
could not understand perfectly breeding. Now it told us, sir, it is very wonderful words. So no, anyone can select, but
Yeah,
it's very easy. But uh, no one can reject. Very difficult.
yeah. For
Yes, sir.
rejection of germplasm, you need knowledge and experience.
Yes, sir. That is one. Today I learned that is new word. It is very wonderful, sir. But even
Only knowledge is not the thing or only experience. You need the combo of knowledge and experience.
yes, sir. Yes, sir. So that I want to again one more session, sir. It is not like, sir. As for myself, sir, it is like a pickle. I'm not eat. You every day you are giving only like pickle for us. That is time. No much time. That is not. That is a fact, sir. Actually, we need more like tiffin with you. That is very important.
Yeah, yeah. Sir. I got your point. Yeah. So, any more
Yes, sir.
questions
Sir,
No, sir.
from student side?
yes,
Expecting
sir,
from student side.
sir, maybe you can call it a silly question, but just I'm wondering how this input data is generated in this output format. Like, of course, from the programming, but how it is able to access like C1 character will get this much percentage from the genotype from the environment.
You can
So,
see here screen. So all this data, we only imported in software, right?
yes, sir.
So that software automatically it will calculate everything and it will give the representation.
So, to what extent we should trust this data also?
You
The
can
output
use your
generation.
experimental data, any data you can use, no problem.
Okay, sir.
Just I am showing as an example. You can use your data and you can try. If you have 100% correct recorded data, you can try. It will give the result.
Okay, sir.
If you have trust on your raw data, you can trust this analysis also.
Yes, sir.
Sir, when we will learn
So,
about data normalization?
yeah.
Sir, when we will learn about data normalization using R?
Yeah, data normalization session, madam, I taught in afternoon. So we'll keep with one session is there tomorrow. That is analysis of heterosis and combining ability. So with that, I
Yes.
will take that normalization.
Okay, sir.
So you will say like technology. So no matter even for genome-wide association and QTL mapping, for each and every analysis, your raw data should be 100% correct. If your raw data is wrong, no technology can do anything.
Sir, you told about
Your field data should be correct.
sir, when you are taking that cluster, sir, diversity.
Just a day after tomorrow.
Okay, thank you, sir.
Okay, sir.
So no analysis and no technology will save you if your data is manipulated. If your data is correct, you can do anything. Yeah. Any more questions you can ask?
So yesterday you told to do stability analysis with Eberhardt and model.
Yeah. But that we will conduct tomorrow.
Okay.
Tomorrow we will conduct that 2 models, then heterosis and normalization. All 3 parts we will conduct tomorrow.
Okay.
Normalization is a simple thing, but here it is, we will do that so that it will be helpful for many of you.
Yes, sir.
So one more request, can we spend some 15-20 minutes more tomorrow?
Yes, sir. No problem.
Yes.
Means after 8 I'm asking some 20 odd minutes.
Okay, sir. No problem.
If you all
Okay, sir.
if you all are ready,
Yes, sir.
Yes, sir.
If it is possible for you and everyone day after tomorrow, sir.
yeah, madam.
If it is possible for you and everyone to conduct this extra class time day after tomorrow.
No, actually, what my plan is, I need some 20 extra minutes tomorrow and day after tomorrow, 2 days.
Yeah, sir, it could be possible.
Okay, sir.
Okay, sir.
Because just because by means first we will learn that thing, and then for some time we will practice.
Okay, fine, sir.
And the 2 sessions we have rescheduled so that we will conduct in continuation. So no problem, 2 sessions you will not lose anything. The 2 sessions we will conduct. That last 2 sessions we will use for genome-wide association analysis using GAPID, Farm CPU and Tassel. Yes, Jaiswal madam, you are saying something, your voice is not clear.
Sir, I'm saying that GWAS analysis will be helpful for me because this for my PhD work I am doing my thesis on GWAS only.
Okay.
Yes, sir.
So that GWAS we will see by Tassel, GAPID and Farm CPU, all 3.
Okay, sir.
So that you can compare all 3 results, and which one will be better according to you, it's up to you, but you can compare.
Okay, sir.
Yeah. Now just can anyone tell me that in first class we have estimated genetic variability parameters. So what is the use of that genetic variability in our plant breeding especially? Just you can speak, your responses are recorded in this video, so no problem, you can speak.
Sir, so that we can
What
know
is
that
the
our
use?
data is sufficient. Sir, so that we
Yep.
can know that
Huh?
data has sufficient variability or not.
So if data is having sufficient variability, what next? What it provides us? If variability is there, what it provides us as a breeder?
Sir, we can
Sir,
go for hybridization or heterosis breeding.
That means what a simple term I'm expecting.
Selection should be effective.
Yeah, correct.
yes.
So it will provide us a selection potential. If we have a sufficient variability in our breeding population, so it will provide us a selection potential.
So some people are not able to on their voice call, so they told to see the messages also.
Okay.
Just a second, sir. How many of you are
Yes,
not able to
sir.
on the? Can you raise the hand? Those who are not able to on their mic, please raise your hand.
Sir, hello, sir. Hello. Hello.
Just take a second, sir. Let me see how many are facing problem.
Hello, sir.
Only one.
Hello.
Udit Jyoti. Once click on your mic.
Actually, my audio is clear, but I'm not able to open my camera for recording purpose.
Camera because of network issue. Anuradha.
It is because of software issue.
Yes,
Okay,
sir.
no problem. You are also able to speak. What happened?
No,
Pradyumna
sir,
Maurya.
I am able to.
Rhythm
Yes, sir.
Maurya.
I'm audible.
Pradyumna Maurya. Can you hear me? Pradyumna Maurya. Pradyumna Maurya is in library. So it's not on in the mic. Even everyone can. Sir, you can continue.
Sir, I have one doubt. Hello.
Gopal sir.
Yes.
Yes, sir, I have doubt related to genetic variability. If our population has a high variability, is it
Okay.
necessary to have a desirable variability? Should we focus on desirable variability with high variability?
So desirable variability means what? Just tell me according to you.
So according to me, the presence of variability means the population having a variation in the character.
Okay.
That is,
Then, so that's what my next question is. So according to you, especially students, as experience, if any experienced personals are there, he may know. So what is the role of heritability in genetic variability?
again, sir, I know the amount of variability that can be transferable to the next generation. That is explained by the heritability.
Okay, so when can you tell like working on this specific trait is desirable? As there are number of traits breeder will deal, but when a breeder can tell that working on this trait in further generations is desirable?
Yes, sir. If the heritability, that is specifically the additive component
So
of that
how much
heritability.
percent heritability?
More
Other
than
members also.
60%.
Yeah.
Sir, at least 80%. You also told
Yeah,
that.
continue. Meena sir, continue.
Sir, one day you told that at least 80% heritability minimum is required.
Yeah. Yeah. Yeah, so Akshata madam, yeah, we can do QTL mapping in R Studio, but it is a separate program called RQTL. So generally, for QTL mapping, many people will prefer ICI mapping software. ICI mapping version 4.2. You can go for RQTL also, but that is a separate, a big program. So it will take a time to learn. You can learn it slowly, but if you want result, you can go for ICIM mapping. Just the name I have given in chat box. So just can anyone tell me what are the different factors which are used to estimate the variability? What are the different statistical factors?
So ANOVA, GCV, PCV, heritability.
Genetic advance has percentage of mean also, sir.
What about coefficient of variation?
So GCV and PCV will come in that.
No, that is genotypic coefficient of. I am asking simple coefficient of variation. Does it affect?
Yes, sir, because it depends on mean and standard deviation, so it will affect.
Yeah. So along with all those you have said, this mean and standard deviation and coefficient of variation are the factors. So as you have told GCV and PCV, so which one will be greater? GCV will be greater or PCV will be greater?
PCV.
PCV, sir.
PCV
sir.
will be better, sir. Because it also have environmental coefficient of variation.
Yeah.
Yes.
Yes, including.
Sir, I have one doubt. I have
Yes,
seen that the people are calculating genetic variability for hybrids. They take the many
Okay.
hybrids, carry out the genetic variability among the hybrids. What is the use of that one, sir?
So actually, generally we use this genetic variability parameters in screening of our parental lines.
Yes, sir.
Yeah.
That is okay, sir. Screening the parents is okay, but they do for hybrids, even though the variability in hybrids is not transferable. Heritability.
Actually, that thing it will not get means it will not as an outcome as it is there in genotypes.
Yes,
So
sir.
if you will go for F2 onward generation, you will get something to work on.
Yes, sir. Yes, sir. But my point is, what is the use of doing variability among hybrids?
So actually, as far as my knowledge on F1, it is of no use.
Yes, sir.
From F2 onwards, it will be helpful.
Yes, sir. I've seen in many papers they have done that.
Yeah. Means if any paper is there on heterosis combining ability, instead of estimation on genotypes, they will estimate this variability on their hybrids.
Yes, sir.
Yeah, so any other questions? You can raise.
Sir, one question, sir.
Yeah.
Sir, instead of broad sense heritability, why we are not using narrow sense heritability?
Where?
For calculating, sir, this heritability parameters.
Monica madam, you can use this R Studio in your social science for the analysis of your survey data visualization, whatever the surveys or social networks, you will collect the data. So for that, you can use this R Studio.
Sir, how many members? Like above 300 or below 300?
So your voice is not clear.
Okay, sir. 1 minute, sir. So, like, how many members should be there? Like above 300 or below 300?
No, it will depend on your data only. No problem.
Okay, sir.
It is not like you have to give input of only 100 data or 150 data. That is not an issue.
Okay, sir. Thank you, sir.
Yes, Vivek. Just you can ask your question again.
Sir, like in previous classes, we used broad sense heritability parameters, like greater than 80, 60%. Instead of that, why we are not?
You are saying in case of this genetic variability.
Yes, sir.
Huh?
Sir, why we are not using narrow sense heritability parameters, like narrow sense heritability?
Narrow sense heritability in estimation of variability in case of broad sense.
Yes.
Sir, I have one doubt.
Yeah, let me clear this first. Hello.
Because, sir, in narrow sense heritability only we see additive genetic variance. That is better, sir.
That's why. And here you will see additive, dominance, and epistatic, all three.
Yes.
Hello, sir.
But, sir, in R software we get broad sense heritability, not narrow sense heritability. How, sir?
Broad sense only, as it is responsible for all the three. So it will give a broad sense.
Hello, sir.
Yes, sir. Ask question.
Vivek, if you will be going for generation mean analysis, then
Meena sir, your voice is not clear. Your voice is not clear.
Sir,
hello, sir.
If
now
we are going for the analysis of generation mean analysis, then we will get narrow sense heritability in that case too.
Some disturbance is there, Meena sir, from your
sir,
side.
Am I audible now, sir?
You are audible. You can ask.
Sir, I have one doubt related to basic breeding, sir. In the three-way cross, they cross the hybrid and the inbred line.
Sir, can you speak somewhat loudly?
Sir, in basic breeding, that three-way cross, sir. They cross hybrid and the inbred line.
Okay.
Do we always get a similar F1, sir? Because hybrid produces a different kind of gametes. Is there the three-way hybrid is all three-way hybrids are similar like F1 hybrid? Are they homogeneous?
So sometimes if your any particular character is governed by recessive genes, like you will see in vegetables, like your disease characters. So if that your trait of interest is governed by recessive genes, then that expression will be different. It will not be same.
Okay, sir.
Yeah, Shivani, we can go for D square divergence analysis in R Studio. Ranjita madam. Hello. Yeah, so I have shared the QTL mapping software photo in group QTL ICA mapping version 4.2. Yeah, the genetic divergence analysis, Shivani madam will do day after tomorrow. The link and photo of ICI mapping is there in group. We'll take, but if you want, you can try. No commands, nothing, only it will take your phenotypic and genotypic data. If you want to try, let me know. I will share one genotypic data file. But just one small suggestion. Before going into analysis, just go through a brief basic. Just like tomorrow we will do heterosis and combining ability. So just read the basic of what is heterosis and what is combining ability. So it will be easy for you to understand the analysis. So any more questions? Just you can ask. If anyone is having any one question, just you can ask. Yeah, Shiva. Okay, over. So just go through some basic points of heterosis and combining ability. So tomorrow morning I will share the data file with you along with the codes.
Hello. Hello, sir.
Yes, Ranjita madam.
Sir, I want to ask that I'm working on fall armyome resistance in mini core collection, 242 genotypes.
Okay.
So I have 2 season data, screening data, and traits are same
Okay.
for those 2 seasons. I want to pool the data.
Okay.
But
Okay.
before that, I'm checking for homogeneity of variance. But
Just simply then Bartlett test is a good option.
Yes, sir. I tested in that, but it is showing it is not homogeneous. Means it's non-significant. So what further? What should I do if it is not homogeneous variance?
Means your mini core data 2 years or 2 seasons.
2 seasons.
So you are working on
sorghum mini core collection for FAW resistance. Fall armyworm resistance.
saying you did this Bartlett test data.
Yes, sir. I have tested in Bartlett and Levin test, but it is not homogeneous. Then I'm fitting that in linear mixed model by giving weights as unequal. Means even though variance is not homogeneous, we can do that, but it is not coming in R. So
You tried this analysis also.
yes, sir. I have tried, but it is showing error. Means
Wait.
proper.
Some network problem from my side. Now it is clear.
I
Some
have
network
tried, sir,
problem
but
was there.
some error is coming.
Can you share that on my WhatsApp, madam? I will tell you.
Okay. Sir. Today I will share you.
Yeah. Just share it. I will get back to you.
Okay. Thank you.
So tomorrow morning, I will share that data and code for heterosis combining ability along with normalization. And along with, first we will take this Eberhardt and Bluff analysis. So all these things I will share in WhatsApp group. Okay?
Okay, sir.
And we'll continue this tomorrow's session maximum up to 8:20. So 15-20 minutes. Just give me tomorrow and day after tomorrow.
Sir, where do you get this script, sir? Do you write your own this script or you get from somewhere?
No, actually, I did my PhD from ICRISAT. So
Okay,
there we worked with bioinformatician people. There is separate department is there, as many of scholars may know.
Okay, sir.
If you want to explore this R Studio, you can go to that R Studio forum, or you can go to the GitHub pages, GitHub.
Okay, sir. GitHub.
Yeah, so GitHub pages, there you can explore this R Studio, no problem. On
Okay,
R
sir.
Studio forum also, you can communicate with the freelancers available there. In their free time, they will reply.
Sir, please share that matter, sir. R forum.
Which one, sir?
R forum link,
yes,
sir.
that link I will share in WhatsApp group, sir. No problem.
Yes, sir.
Thank you, sir. Okay, thank you. We will connect tomorrow 6 o'clock. Okay.
Yes, sir.
Thank you, everyone.